Okay, so good morning, everyone. Today, this is lecture number 6, and we are going to discuss what exactly is a process inside an operating system. We have lastly seen the scheduling algorithms and how the scheduling works to manage these processes. We have only seen how operating system manage the processes which are inside the system. How does it create, and everything else about it is not known yet. So today in this lecture, these are my objectives. These are the objectives that I'm going to cover. My objectives would be to introduce the notion of a process. What is basically process? What all are the concepts of this process? Then I'm going to explain the various features of these processes. What are the features? What are the attributes of the processes, including the scheduling of these processes, the creation, the termination, and the communication. Then we'll understand, and I'll just try to make you explain and explore the inter-process communication which is there in between the two processes. The two processes tries to communicate using a mechanism which is called inter-process communication. So we'll understand this topic. And then finally, we'll just understand the client server system. And let me just tell you that all of these things cannot be, completed in just a single lecture, because it is a very in-depth study that we are going to see. So most probably, I'm just going to continue this lecture in lecture number 7 also. We'll be starting today, and the point at which we can complete is about the processes, and inter-process communication can be later on in the next lecture. So please be with me and just understand the concepts of processes today. So let us just quickly go through the processes. So I'm sharing you what all are the topics today that I am going to cover. So these are the topics that I'm going to cover. It is process concept, process scheduling, operations on the process, inter-process communication, examples of inter-process communication systems, then communication in client server systems. Okay. Now these are the points. These are the 6 points that I'm going to cover today to understand what exactly is a process. Let us move further. Okay, so see, the very first point says that an operating system executes a variety of program, right? Now it does batch system jobs. Batch system means a batch of the computers have been made with a specific execution time. Then there are time sharing systems where every computer, every system is given a specific time to execute. So even that is there. So, see, what happens is in many online journals, in other study materials, in various contents, online or offline, you will see that sometimes the process is replaced, or it is used instead of using the word process, we use jobs. So, what is job basically? A job or a process is nothing but any kind of program which is in execution. Like it could be anything. You have instructed your operating system to play a song. Now even that is a process. Once your song will start playing, it will act as a program in execution. So I would say technically your song is playing in a layman terms, but technically what is happening internally, I would say that it is a process. It is a program which is in execution. It is a song. It is a file which is playing itself, right? So this is basically the process. And the process execution must progress in a sequential fashion. That is also an important part. That whenever your program is in execution, it must happen sequentially. It must happen linearly. You cannot have it like that. That first some part of the program has been run, then another part of the program is running. No, it should run in a very sequential manner, right? Now a program, a process has got multiple parts. What are they? See, it has got a program code, and a program counter is there, which is used to store the address of the next instruction which is going to execute it. Then it has stack, which contains temporary data. The stack can have functional parameter, it can have return addresses, it can have local variables. So all these things are there. Then the the process, it has got a data section. That data section consists of global variables. Similarly, a heap is there. What is heap? Contains memory, which is dynamically, allocated during runtime. So these are all the things which are there in your, process concept. So let us just see further. Now, see, the program is basically, it is a passive entity which is stored on the executable file, but the process is active. Now, understand what do you mean by this statement? What does this statement says? See, the program is passive. Program is passive means, see, what happens is, by program, we mean that a piece of code is already lying inside your memory, whether it is on the disk or it is stored somewhere. So we'll say that the program is kind of a code, a kind of the lines of code or piece of code which is already there in your memory. It is residing. It is saved in your memory, and it is of no use until you execute them, right? So it is just an executable file. So that is why it is passive in nature. It is there, but currently it is not running. That is why we are saying that it is passive in nature. But if you want your program to run, and as soon as you run your program becomes a process, and then it suddenly becomes active. Out of passive mode it will come and it will become active, because we already know this thing, that whenever you run a process, the process is required to be there inside the random access memory, the primary memory. So a program which is a passive one, it is residing in your secondary memory, a disk, but whenever you are running it, it becomes a process and it comes in the random access memory. So this is about the process. Now, the program becomes process when the executable file loaded in the memory. I told you this point, I already explained it to you, that in operating systems, whatever you want to execute, you have to bring it back on the random access memory. So this is a point. Then execution of a program started via GUI mouse, graphical user interface mouse clicks, command line entry of its name, etc. Right? So now the point comes that, okay, what we can do is we can make our program into a process. We can change it from being passive to active. But how does it do so? How does this thing starts? Now this starts with the help of, either if you are instructing your operating system with the help of a mouse, with the help of mouse clicks, or if you are using some kind of a device like light pen you are using a joystick, or leave everything else. If you are taking use your keyboard, if you are pressing a single key, that key is instructing your system to open a process, to start a process which is already there. Let's say if you are pressing a key with the word C, right? Now C, for C, your code is already there. Behind C, the coding, the piece of code of C is already existing in your system. But once you click that C, the program become active, and it converts into a process. And as soon as you click it, the operating system will rise up, and it will instruct the further systems to do whatever you are instructing it to do, right? So this is how a process gets initiated. Now, one program can be of several processes. Okay. Now, what do we mean by that? See, a program is not a single piece of code. It is a multiple piece of code. It could be multiple piece of code. So there could be a chance that sometimes we need to parallelly run all the processes residing inside the program, right? And sometimes it can happen that the processes can be taken up sequentially in a manner. So there are the chances that the program can be taken up, or the processes can be taken up in a sequential manner, because a program is a collection of several processes here. So this is about the process concept. Let us take up the next point. Now, as you can see, this is a process in memory, right? You can see this diagram is, I guess this is visible to all of you. Now this is a stack, and let me tell you, a process always takes use of stack, right? um, it is very beneficial, and I'm going to later tell you on that why the stacks are mostly suitable. That is why the process always, take help of an auxiliary data structure, which is all the time, which is static. So here, see how a process is working. This is a complete process which is lying inside your main memory. The bottom part, the lowest bottom part, consists of the text. Then you have data. After that, there is a heap. Then you have some free memory in which you can, put some data if you want at the time of execution. If there is some value which needs to be stored here, you can store it as well, right? And on the top of the stack, which is called TOS, TOS, it is a pointer which is pointing to the topmost part of your stack. So here it is topmost part of your stack. This is your stack, right? So I hope this one is clear to you how a process resides inside the memory. Now we come over to the states of processes. Yes, even a process has got its own life cycle, right? A process has got its own life cycle. Yes, the operating system used to give birth to a process, used to create a process, and as soon as the utility, the use, the application of that particular process completes up, your process needs to be terminated, your process needs to be ended up, because we have a limited memory, and using that limited memory we cannot generate and create lots and lots of processes which will grab the memory, and suddenly your system will get crash. So this is a case that as soon as you create a process and you use it for a particular, for a specific task, after using and after taking use of that process, you need to terminate it any condition. So let us now just see that what all are the states of the processes. So first of all, see, as a process executes, it changes its states. Now, what are its states? First of all, in the process life cycle, this is what, this is just a process life cycle that we people are discussing here. Now, the very first state of, or you can say the very first stage of your process is the new stage. Now, what is this new stage? This is a stage where your process is being created. Operating system is creating your process. So this is the newest stage of your process, where your process is getting, created. Then the second stage is of running state. Now, once your process has been created, uh, it comes into the running state. It can be in the running state. How does running state says? Now, running state means it is getting executed. It is getting active by being processed by the central processing unit. So, running state is the execution state. Third state is called the waiting state. Now, waiting state is what? See, it could be in two conditions. A process can be in a waiting mode for the two reasons. One reason is that the process is waiting for some kind of an event to occur first. Like for example, say, let's say if I want to present a PPT to all of you, then until that PPT comes into the picture, until that PPT opens up, I cannot start speaking. So for this task, let's say if I'm taking the process to be speaking, for the mic's function to work on, I first need to open up my PPT to read from it. Now, this is basically the waiting stage, where a process is waiting to other for the other process to execute first, and once it will get executed, the other process will start quickly. This is one reason. The second reason could be that, let's say, a process is in need of some kind of resource. In need of some kind of resource means, let's say it requires some kind of a file to get open, or let's say it requires some kind of address to be fetched, or it requires some data to be accessed. So in that case, when all the resources and the data which your process is requiring, they are not available to your process, in that case your process goes into the waiting state. So see, This is one important part. You must understand this thing, that a process can only be executed in the case if your process has got all the resources and the data and the information required by it. So until it has got all the things, it will always wait for them. The processor, the CPU cannot execute it at any cost. So this is the waiting state. Then there is a ready state. This is a signal, this is a symbolization to the central processing unit to say that your process is ready with all the resources and the data which it requires. The only requirement is the CPU time. It requires the CPU to focus on this process, to take the process and to execute it. So the ready state is always a state which is inside the ready queue, and it always signals your central processing unit that I am ready with all my resources. I just need your time and please execute me. So this is the point that your ready state says. Then the last stage is of termination state. As I told you, if a process is created, it has to be destroyed also. So once you are done with the execution, your process has already been run. Then in that case, what do? We need to terminate the process. So how do we terminate? There is an option. There are some functions of operating system. There are specific functions which are meant for doing this. They terminate your process as soon as it has completed its execution part. So these are the important states of your operating system, and you can even call them a process life cycle, because a process gets created, then it gets ready, then maybe for some time it can wait, then it will go in a running mode, in an execution mode, and once it gets executed, the last step is of termination, so it will get terminated. So I hope this one is clear to you, how the process life cycle goes on. Let us just quickly understand it with the help of a diagram. So see, this is your diagram. Now it is showing process state, or say it is showing the process life cycle. How does it show? See, there is a new process which is first of all admitted, right? A new process is created by your operating system. Then it is getting ready. How it is getting ready? It is getting ready by grabbing all the resources, data, information which it requires for the execution. So this one is getting ready. Now, see, there could be a point after getting ready and after signaling to the central processing unit that yes, I am ready for execution, please take me for the execution. There could be a chance that, okay, CPU has seen and CPU has taken this process in the running mode, in the third mode, but somehow some interrupt has been generated. What do you mean by interrupt? Interrupt is kind of forcibly stopping a running process just because a higher priority task breaks into it, right? So if a higher priority task comes in, then in that case every running process has to come to a pause mode. It has to stop its working for a while and it has to move to the disk part. So this is a context switching part. This is called context switching. So in context switching mode, the process has to be has to leave the random access memory and it has to go to the secondary memory. So as soon as this interrupt will occur, what will happen? The process has to wait. The process goes into the waiting stage, and once again, if the processor is ready to take it, it has to move to the ready state, and again it is given to the running state. Now once the execution gets completed, in that case the process can exit and it can terminate. So I hope this process state is already clear to all of you, that how a process comes into picture, how it gets ready, how it fetches all the data and the resources, how does it run, and how does it react when an interrupt is being generated, how does it go for waiting state. Yes, the waiting state can also be there when suddenly while you are running your program, your the CPU doesn't find any specific resource or an input output event. So in that case, your process will go into the waiting state again. And after that, once you are done with all the things, your process needs to be terminated to save the memory. So this is all about the process. Okay. Now, to organize, to manage, or to execute your process, there is a specific data structure that a process use. What is a data structure? A structure which is used to organize your data. So there is a organized data structure which is there. It is called process control block, or shortly we can say PCB. Now, what is it? It is the information which is associated with each process, right? See, in previous slide, I have told you that a process, first of all, needs to be created before its execution. So let me tell you this important point that for every process of your operating system, in operating system, once you create a process, every time a process is given, is allotted a special information which is called process control block. It is given to each and every process. Why? To have some few information about it. So every process has associated, or a process has got a process control block to store some kind of specific information related to it. Right. Now, what does this process control block covers up? Here you can see this is the the structure of a process control block that you can see over here. Now understand what all are the blocks, what all are the the datas which are residing inside it. Now first of all, the very first part of this process control block is the process state. So first of all, for a particular process, you have to store the state of this process, that whether this process is in running state, is it in waiting state, or it is a ready state, whatever it is, you need to write the state here. Or in fact, you people are not writing it, the operating system does it so far, right? So process state has to be written here. Then the next point, the next field is the program counter. So program counter is what? The program counter is basically a part which always store the address of the next instruction which is executed. As I told you, that process is nothing but a program in execution. So in a program, there are pieces of line. There are a line of instructions which are there. So let's say one line is already executing. Now this is the time to or the processor should know in advance that which line is going to execute next. Now, in that case, the address of that next instruction needs to be stored somewhere, and this is the field where actually it gets stored. So, program counter is nothing but a point, a space where your next instruction address is residing, right? Then the process number. This is the process number. So if your process has got a specific unique ID, that unique ID is always stored in the process number part. Okay, so you are going to store it here. Then you have CPU registers. Okay, now CPU registers are always meant to store the memory. So whenever your process is in execution, for temporary ways or temporary purposes, it needs to store your data every now and then. Now for those purpose, for this kind of task, your CPU registers are used. Registers are nothing but the memory saving entities, the things which are used to store the data. So register should be there. Then you have CPU scheduling information. What is CPU scheduling information? See, scheduling by scheduling information means that let's say if your process is kind of a prioritized process, some kind of priority is assigned to you. If you remember, in last class we have seen priority scheduling, where I told you that in priority scheduling, each and every process is assigned some kind of a unique priority. So this is the case which is related to CPU scheduling information, where each and every process is given or assigned some kind of properties or priorities to it. Other information can also be there regarding your process, some kind of instruction which you want to give. So anything related to the scheduling information is inside the this part, right? Then the next is memory management information. Memory management information means that how much memory your process requires, its memory limits, they are defined inside this part. So the process control block consists of this part also, where it always signifies, it tells your CPU that how much memory it will require for the execution. So this is memory management. Then accounting information. By accounting, what do we mean here? It is see, it tells that how much CPU time the process has taken, how much time it has elapsed, what is the time limit. Because see, it is always a case that your operating system, yeah, or say your process is always required to complete at some particular time. So it has also got its limit. So in that case, we need to understand this thing that accounting, some kind of accounting information should be there inside your process control block, which will always tell that at what time the CPU has started the execution, at what time some kind of interrupt has been generated, or at what time the process got inside the waiting state, and how much complete time, total time it has taken to get executed. So on the basis of that, we are going to judge that whether the execution was very efficient in terms of time and space, or is it not. So this is all about the accounting information which is stored by the process control block itself. And lastly, the input output status information. What is that? Now, see, input output devices allocated to a process, there could be list of open files, whatever things are related to the input output, mechanism of a process. All these information are always stored in your process control block. So I hope this one is clear to you, that what is a process control block and why do we need it. But just remember one thing, that every time whenever you are dealing with a process, every time a process get created, it always have one process control block to store all the information related to it. Okay, so this is one important point that you have to make sure of. Now, this is CPU switching from one process to another. You can see here, this is process 0 and it is executing, right? Now, while it is executing, let us just see the role of operating system. Let's say if there is a system call, or there is some interrupt which occurs while executing, what happens? You need to save the state of P0. Save this state, what do we mean? That you need to save that particular stage, the last moment at which it was executed. You need to save that point somewhere, because once the CPU is again allotted to this process, it will resume its functions. It will not start from the beginning, it will resume from where the last it has left out. So that particular state is always stored in your process control block. Then there could be reload state from PCB1. There could be some point where the process is switching from one state to another. So in that case, that is to be reloaded. There could be a case when your process gets idle. Then even in that case, it has to be given to another process. So this complete diagram shows you how operating system manages and operates different processes on the basis of interrupts generated, or on the basis of system calls. So here are the examples. Sometimes when your process get interrupted, then in that case it sits idle. See here, process P1 is idle. Why it is idle? Because at that particular time process P0 is already running inside your CPU, and your CPU, as I already told you, is capable of executing one process at a time. It cannot execute multiple processes. So that time, if you're executing one process, let's say process P0, then you are seeing this process P1 is sitting idle for that time. So this is the case. You can see from here. Then comes the part of threads. Now, so far what we have learned is that process has a single thread of execution, right? Now, what is a thread basically? See, thread is again a program in execution. Okay, the technical definition of a thread says that a process is nothing but a program in execution. So every process has a single thread of execution, a single program of execution, right? Now consider having multiple program counters per processes, which would be too large for us. Okay, we cannot do such kind of things. So let us just see here how you are going to represent a process here. You can see in Linux operating system, we are representing the process. So how do we represent the process here? A process is always represented using a structure. Structure is what? It is kind of a data type, which is a collection of dissimilar data. Dissimilar means some of the data inside it can be of integer type, some can be of pointer type, some can be of float type. So it is just a collection of dissimilar data. And let us see here what all things are there. Like it has got PID. PID means the process ID, the unique ID which every process gets once it gets created. Then the process identifiers. There are some other numerical values which are called identifier, which are used to identify a particular process. Okay, so this is PID. PID is what? It is a process identifier. Then there is a long state. Long is what? Long is just a data type which denotes an integer. But this long data type takes up large memory in comparison to int. Int is of 2 bytes only, but long takes up 8 memory. So long is just a data type, and uh, we have taken state as a type. So what is state? Whatever state your process is in, like if it is in waiting state, it has got a number. If it is in running state, it has got a different number. So the state signifies the in what state your process in. Is it in creation state, is in ready state, or it is in waiting state, whatever it is. Then next is the time slice. You need to give the scheduling information, that at what time it has got, yeah, at for what time your process get executed. So this is the time slice. Then again, we have used some nested structure inside it. You can see these four nested structures. What are they? The task struct. Task struct means the parent. So see, every time whenever you are creating a process, do remember that every created process has got its parent process. So it is not the case that automatically a process is generated by an operating system. No, there is always a process which acts as a parent process, and it gives birth to a child process. So this is the information of the parent, that which parent has executed it. Okay. Then we have the children. This process, children. Obviously, if a process has been created as a child, at some point of time, it has give birth, or it has to create some other process. So at that time, it will be acting as a parent. So at that moment, it needs to give the information of its children also. So see, there are two things. The process has to give information about its creator and about its successor also. Both of the things are required, right? Then here you see the next nested structure is of files, where list of open files you have to mention that what all are the files that your system is requiring. And then finally, by we mean what is the address space, what is the memory management criteria of your process, how much space it has got, and what is the address of that process, right? So this is all about the process representation in Linux. In Linux, we used to represent the process like this. In your operating system, these are the fields which are used to define a process. This is how your process gets represented. Okay, I hope this one is clear to you. Then we are coming over to the part which is called process scheduling, and we have already seen this in fifth lecture, where I told you that because there is a limitation of your central processing unit, that it cannot execute all the processes together. That is why there is a lot of scope for management, a lot of scope for scheduling. We need to schedule. We need to make a plan that how each and every process should be executed, because every process is important to your operating system, and every process needs the time to get executed. That is why it is a very major task of your operating system to schedule all the process, so that no process should be left out for the starvation factor. Okay, now understand, as much as processes will get executed, will get scheduled, your CPU usage will be maximized, and it can quickly switch between the processes on the CPU from time sharing system. So, for doing all these tasks, an operating system employs a specific program which is called a process scheduler, because operating system, cannot take control of all the things at the same time. It has to do a lot of work. It has a lot of aims, a lot of roles to, play. So it gives this task, it disseminates this task to a separate kind of a program which is called process scheduler, and this is the process which takes up, or which controls the scheduling part. It selects among the available processes for the next execution of the CPU. It is its job to decide which process is going to execute it first and which process has to wait a lot, right? Now, for doing all these things, for scheduling all these things, a process, or the process scheduler always takes use of some queues. Like one of the queue is a job queue, wherein all the processes of the system will reside, right? Then we have ready queue. Now ready queue is that queue which is a queue which is always given to the process when it is ready to be executed, when it has got all the resources and the data which it requires. So once it has got all the things, then you can run the process. Then you have device queues. Now, what are device queues? There are set of processes which are waiting for an input output device. So this queue is used for that. Okay. Then process migrates among the various queues. Obviously, once your process is inside, let's say it is in device queue, then once it has got all the resources and all the data to be executed, it will be shifted in the ready queue. So this transition of states always happens in your process. Your process can be in one queue and then it is transited to another queue. So this transition always occurs at some moment of time. So this is all upon the process scheduler, that how it is going to schedule and manage all these things. Right? These are the various queues you can see here. This is a ready queue, and let me tell you, all these queues are running with the help of linked list, right? In a dynamic manner. So every queue has got a header. Header always shows that where the data is residing, at what address the data is residing. So this is how you see. These are the register. These are the process. This is one process. Like it is the seventh process which is residing. There could be some more processes also. Similarly, after process 7, you have process number 2. So there could be anything like that. So each and every, you can see this, each and every block is representing a single process. This is process number 7, this is process number 2, this is process number 6, this is 14, this is 3, this is 5. So in that way, they are distributed everywhere. So this is your ready queue, this is some kind of different queue. So there are lot many queues in which the transition of a process occurs from here to there. And this is your queuing diagram, which is showing the representation of the process scheduling. Okay, this is process scheduling. There is a ready queue, and there is input output queue, child executes, input output request is given, time slice expired, then a child executes. Sometimes it can be one interrupt that could occur. So after a thing of interrupt, your process again gets ready for the queue, and it is always assigned to the central processing unit for the execution. So this is all about the queuing diagram, right? You can see it from here. Then we have different categories of schedulers. There are three types of schedulers. One is short term, one is long term, and one is middle term scheduler. But majorly we use short term and the long term scheduler. So by short term scheduler, what do we mean? It is a CPU scheduler. The other name of this is CPU scheduler. It selects which process should be executed next and allocates CPU. Sometimes the only scheduler of the system it is, right? And it is invoked very frequently in milliseconds. So it is a very fast scheduler, right? Second category of scheduler is long-term scheduler, which is also known as job scheduler. It selects which process should be brought into the ready queue. So long-term scheduler is invoked infrequently. It is very slow in nature, and it's it is called once in a second or once in a minute. So the long-term scheduler controls all the degree of programming. So see, a process can be described as it is an input output bound process, or is it a CPU bound process? So if you have input output bound process, it spends more time doing input output than computations, right? And if you are opting for CPU bound process, then it spends more time doing computations, and it has got very long CPU burst time. So long time scheduler strives for a good process mix. It always required to do so. Okay. Now, as I told you, there is a third category which is called medium term scheduler. Okay, so we have already seen this thing. Um, Midterm scheduling or medium term scheduling part. So it can be added if a degree of multiple programming needs to be used. So to remove the process from the memory or to store it on a disk or to bring it back in from the disk to continue execution. That is called the swapping part or the context switching part. In that case, medium term scheduling comes into the picture. Okay. So this is all about the three types of scheduler that can be used for the scheduling purposes. The process schedulers take use of these three types of schedulings or the schedulers. So I hope this one is clear to all of you. Now we'll move on to the the MCQ part where we'll understand that a few people have understood the concept of the schedule. So, my dear friends, you have seen today the concept of process we have gone through, and you have seen how a process gets created by the operating system, how it moves on to the or transits into different stages, and how does it gets terminated. And during this, during its course of execution, what all are the things which are needed? We have seen the process control block, how it works out, how all the informations are residing inside it. So these are the the important information that we need to take up. These are all the things that we have seen that includes a process. So we have seen today all about the things about the processes. However, they are not limited to this much of information. A process is a very wide concept that we need to ponder upon. So there are a lot many things that we can go through. Now, as by today, whatever we have learned about the process, about the process control block, about the execution of the process, about the states it has got, different states, about the process life cycles that we have seen. Now, on the basis of that, I am going to give you an MCQ that you people needs to appear and just check your knowledge, whatever you have gained, whatever information you have acquired. You just need to put all of them inside the MCQ and just try it out if you people are able to attempt it quickly and correctly. So I'm just going to present that MCQ to you. So I'm stopping my presentation over here. I hope all of you will be able to see this. So these are the MCQs. They are very, easy. If you have learned the lecture, today's lecture very thoroughly, then in that case you'll be able to easily answer all these questions. So the OS maintains all the process control blocks in. Where does it store? Is it in process scheduling queues or is it in job queues? Is it in ready queue? Is it in device queues? So you need to answer this. Secondly, the processes which are blocked due to unavailability of input output devices. I told you in the in the condition where your process is lacking in the resources, if it hasn't got the sufficient number of resources, then in which queue it needs to be remained. So these are the four options. Is it process scheduling queue? Is it a job queue? Is it a ready queue? Or is it a device queue? So you need to decide upon this. Then the next set of questions. Two-state process model refers to running state or non-running state, or it could be both A and B options. Okay, so this is very easy. And then which is not a type of scheduler, long-term, short-term, medium-term scheduler, or none of the above. We have seen three types of schedulers already, so you people might be able to answer it very quickly, right? Now we have which scheduler is also called a job scheduler. So I have told you the other names of both the schedulers. For short-term scheduler, for long-term scheduler, they are a different names suggested for them. So you people will be able to answer even this question also. Now let me take you to the next set of questions. Question number 6 and 7. When the suspended process is moved to the secondary storage, the process is called swapping out, swapping in, swapping, or process mix. I told you because this is a general procedure where a running process has been interrupted preemptively, forcibly, and it is saved. The particular state is saved inside the secondary memory, and once the interrupt get completed, your process you know uh, move further inside the random access memory. Now, next one is which scheduler speeds it fastest? Is it long term? Is it short term? Is it medium term? Or is it swapping part? So I think you are able to answer it. Now the next set of question is which scheduler is a part of time sharing system? Is it long term? Is it a short term scheduler? Is it medium term scheduler? Or is it a swapping? Obviously, swapping is not the part. Then what part of the system it helps in time sharing system? You are able to answer it, I hope. And then the next question is ninth one, which says a dash is the mechanism to store and restore the state. So, which is this? Is it a PCB? Is it your program counter which does so? Or is it the switching information? Or it is called the context switch? And finally, the 10th question is which of the following information is stored when the process is switched? Is it input output state information, or it has some kind of accounting information, or some base and limit register value, or all the informations are required to be stored once your process is switching from one state to another? So this is again a tricky but an important question, and it is very easy. I have explained this to you in this lecture also. So I hope you all will be able to answer all these 10 questions, and everything will be clear to all of you. So let us just take up the other concept, the further concepts of the processes. later in the process. So let's just stop this presentation over here, and we'll meet in lecture number 7 to understand further more concepts of processes. Thank you so much. Thank you for being here.